All right, get good. Beyond simple commit and push, I think given that Git is something that we use on a daily basis, I think every developer should actually know Git quite well beyond just, hey, committing, pushing, and the rest of it. So I'm gonna show you guys why I'm doing this talk. So a couple of weeks ago, I saw this tweet: use git reset hard without fully understanding the -- hard bit. Turns out it deletes stuff. Thankfully, Time Machine had my back now. And like, this guy is actually a relatively well-known developer. He actually wrote a few JavaScript books, I believe. So even for people like him, a lot of people don't quite understand how Git works. The reset hard part, but also, he resulted in using Time Machine to actually get things back. But I'm going to show you there are other ways, far easier ways to actually get your stuff back. So that's why I'm doing this talk, inspired by people perhaps misusing Git or not knowing the fundamentals of Git. So show of hands, who uses Git command line mostly? Well, it's not bad. Every time I use a Git GUI, I get a bit frustrated because every GUI is slightly different. Therefore, you don't actually know exactly what Git's performing, I guess, in the line, right? So I always use Git command line. The exceptions would be if I need to diff certain things, or if I need to check what's in my Git staging area. I'll use a GUI to sort of look at, what's about to be committed. Otherwise, I almost always use command line. You feel free to use GUI, but I think even if you use GUI, you need to know what exactly the GUI is actually trying to do. Otherwise, you end up having like merge commits and whatnot, which I'll discuss in a sec. First of all, I want to talk very briefly about the Git model. I think Git, a lot of people see Git as something that's really complicated. It's like, oh, there's like so many commands, which is true. But down to the fundamentals, it's actually quite simple. It's all about shars and refs. So I'll get to the next slide. These are the commit shars. They basically a SHA-1 or SHA-256 of a commit. So it basically takes the content of a commit, paired with meta information like your parent commits and things like that, and that derive at a single SHA, and that SHA is, for intents and purposes, unique to your repository. And the refs are referring to things like your head, your master. These are your sort of tags, branches, and what have you. But everything's about the SHA, right? And as a matter of fact, these SHAs are quite long. But for a typical repository, it's very rare for you to run into SHA collisions. So usually all we need is the first seven digits is all you need. And this is what sort of GitHub presents you as well. If you try to paste the entire SHA into your, like, the PR editor on GitHub, it'll actually shorten it to 7 digits for you. So if I've interviewed you, you would have been asked to explain what Git merge and rebase are and the differences between them. It's like, surprisingly, 9 out of 10 devs I've come across during interviews can't explain what the differences are or can't explain them well. Some might see them as interchangeable, some might see them as different, but still couldn't actually explain how to use them or when to use them. So it's actually really simple. Let me try to get rid of this. All right. Oops. All right. So imagine you've got a master branch and your feature branch from old commits to new commits, right? And this is, for the majority of us, this is our typical workflow on a daily basis. You branch off to a feature branch, and then at some point, you try to merge your feature branch back into master, right? So this is a timeline, right? You have master and feature branch, they have almost like interlaced kind of commits. So the commits are, I guess, the oldest commit on the master branch. Then you have two commits in your feature branch, and then master has a new commit, right? So this is a setup. This is a very typical setup that we kind of have on a daily basis. Now, what a git merge does, it's very simple. It literally takes both branches and issue a merge commit, which I'll actually briefly touch on later, and kind of combine them, right? This is what git merge does. It merges two branches without touching the branches themselves, apart from having a merge commit. Rebase, on the other hand, if you say rebase on your feature branch, you rebase on top of your master, this is what it does. It basically groups all the commits in master. It groups all your commits in the feature branch and shift the timeline, right? And one fundamental thing about this is that because you're shifting timeline, you're changing history, all the shards of your commits would have changed. So the contents will be the same, more or less, unless there are sort of conflicts. The shards will be changed. So they're brand new commits. However, they contain the exact same information, almost exact same information. So that way, I guess the commits are grouped together. It's easier to see when you have like multiple feature branches throughout the Git commit history. This is far easier. This is the ideal state because they're far easier to see. This is the, your feature branch A. All your commits are actually grouped together. Instead of, if we go back a slide, instead of sort of littered throughout the timeline, right? So that's the difference. Now, the interesting part is that if I go back to slides with the merge, right? I mentioned the merge commit. Merge commits it's not required. It's actually an optional thing. This is something that I guess a lot of people might not know. Let's say we've rebased without using GitHub to merge in the pull request. If you do a git merge right after a rebase locally, and if you've got a recent enough Git from like maybe within the last 2 years or so, the default behavior is --ff- only. It means it's fast forward. What that means is that your feature branch already contains everything that's in master, and they're exactly the same, apart from the new commits, which means to merge stuff into master, all you needed to do is traverse through the commits and fast forward. And if you notice, there's no purple dot there. So it doesn't actually create a merge commit. So a merge commit is actually optional, right? Now, a lot of times it's actually undesirable to have everything fast forwarded and merged without a merge commit, because what that means is that now if I look at the commit history, everything is linear, and I don't actually know which commits at a time belong to your feature branch because there's no indication anymore. Everything is linear, right? Well, get thought of it. There's another option called no fast forward. And this is desirable once you rebase and merge, because now it creates a merge commit. And in reality, if you see the timeline, it's not quite exactly linear anymore. So these commits will show as based off that merge commit. So you can actually go back and see exactly which commits belong to your feature branch once upon a time, right? So these are very useful. And this is something that I guess some of the GUIs try to hide behind the scenes. Like they will try to detect whether fast forward is needed. Well, you can make it very explicit. you can tell Git exactly what you want it to achieve. Is everyone still following? Cool. Something that I reckon we don't use often enough, we all use git pull, right? This is how you actually pull things down. There's actually something called git pull with rebase. I guess some of you might not have used it in the past. First, let me explain what git pull is. Git pull is essentially git fetch plus git merge. What it means is that git fetch will talk to the origin repository, try to fetch everything down, like all the, basically every single SHA, like all the branches, what have you, everything, it fetches and stores them in your local repository without doing any merging. So if you're on master, you do a git fetch, it'll fetch master from origin, it'll fetch all the feature branches from origin, but it wouldn't actually do anything to them. So your local master stays local. It stays exactly the same until you manually do git merge, or you just do a git pull, right? So pulling is fetch plus merging the local or the branch you're currently on. So it'll only, if you're on master, it'll only merge master without touching any of the other branches. This is important because if you look into our code bases, perhaps admin or some of the other code bases, from time to time, you start noticing that there's like merge commits from origin master or something like that, right? And this is actually created by your Git, either your command line or your Git GUI. Why is that the case? Well, it's because when you have, again, your local, let's say you're on master, your local master and the origin master have different commits. They've diverged, right? Let me see. Yeah, I've got a graph here. So let's say these are the same commits that you have on your local master as well as the origin master. So these are exactly the same. This is what's on origin. So what's on GitHub. This is on your local. And it doesn't matter whether that's master or feature branch, they're all the same. So they have diverged commits, right? And at this point, on your local master, if you were to do a git pull, it'll try to fetch these commits first, and it'll try to merge those commits into your local master. And because the two branches have diverged commits, it'll have to make a merge commit. And this is undesirable because typically we do the other way around. Typically we try to merge feature branch back into master. But this is more like from a origin branch into your local master. And then if you look at your Git timeframe, the merging is all over the place. It's very hard to get your head around what's actually going on. So this is where git pull -- rebase comes in. It basically does a git fetch and it does a rebase first before merges. This is basically what I said before. You try to do a git pull, right? Because they have different commits. It creates a merge commit. -- rebase, on the other hand, it sees those that are the same commits. It sees these are the diverged or the different commits from origin. It tries to rebase those. It tries to rebase your commit on top of the different commits. Yeah. So effectively, this is just like a normal merge, and this is like a rebase, right? That's the only difference. So I usually only use git pull because we typically don't commit things onto master directly, right? But at times we do. And when I know that, there might be a few new commits on the origin that I don't have locally, I'll use git pull -- rebase. And that's how you avoid like those random merge commits. All right, git stash. Do we use git stash? Have we used git stash? Yeah. Who haven't heard about git stash? We all heard about git stash. That's good. So think of git stash as like temporary commits. So if you needed to do something, if you need to like, typically what I do is I know that there are new commits on the origin, but I've been working locally, whether on master or on a feature branch. I just wanted to pull down all the new changes and apply my uncommitted changes on top of the new commits. Then what I'll do is I'll do a git stash first to stage the, I guess, my uncommitted work to a temporary commit, so to speak. Do a git pull to get down all the latest changes from origin, and then do a git stash apply to sort of pop the changes back into the head. So it's very useful as a sort of temporary measure. All right, so git reset. This is the first slide was about someone misusing git reset. Now, git reset is obviously about deleting stuff. There are two different resets for the most part. There are actually three, but we typically use either soft reset or hard reset. The only difference between the two, hard reset, as the tweet said, it deletes stuff, right? So physically gone. Well, not quite. It's deleted. Soft reset, it basically resets or removes the commits, but have the changes in the commits in your Git staging area. So you can make further changes to them and things like that. That's the only difference between soft and hard resets. But I'll talk about how to get things back if you accidentally did a git reset hard. Now, this is something also interesting, git any command and then head tilde n. All right. Do we all know what that is? Have we all used head tilde n? Some of you haven't. Let me explain. Now, a lot of times, if you remember one of the first slides I showed, like, you've got like very long shards, you've got a bunch of shards, right? Git shards. And then sometimes it's hard to remember them unless you copy pasted them somewhere. A lot of times when we work with a Git repo, let's say, oh, I just accidentally made a commit that I want to, remove, or there are the last 3 commits I don't need, or I need to make changes to them. Instead of finding exactly what their shards are, you can just say, your latest commit is the head. The second latest is head tilde 1, and then so on and so forth. So you can just use head tilde 3 to go back like 4 commits. That's what that is. And that can be used with any Git command. So git reset, git cherry pick, whatever it might be. You can always use this syntax. It's like an absolute versus relative way of, I guess, sorting through your commits. Anyone used git bisect before? Do you know what that is? Nope, okay. So I've only used this from time to time. I normally don't use it now. Sometimes, and this is why we use Git, is to keep track of history, right? Your commit history. Now, let's say QA comes up to you to say that, hey, we noticed a bug. And then you will be like, oh, okay, so which commit actually introduced that bug, right? That's a reasonable question to ask. You can either do that manually. Let's say, oh, I remember maybe it was a commit from 2 days ago. So you find out the commit, you check out the commit, you manually try to run your repo and see whether it contains the bug. Or you can ask Git to help you. Obviously, it doesn't help you to fix the bug, but it'll help you narrow down to like exactly which commit actually caused that bug. Now, how it works is that, let's look at from the left to right, right? On the left-hand side, let's say in reality, you have, again, this is a timeline from old to new. So we know the latest commit contains the bug. And let's say the first 3 commits are bug-free. So at some point in commit D, actually introduce the bug, right? This is the reality. but you don't actually know that just yet. So you can say that, okay, you can ask Git, right? You can say that, I know that the latest commit definitely has a bug. And from memory, the first commit that was bug-free should be 2 weeks ago because it was definitely working then. We tested back then. Let's say commit A was from 2 weeks ago. You tell Git bisect to say that this is the last bad commit. This is the last known good commit. And then bisect will narrow down the commits and ask you, like, it gives you it checks out a particular commit somewhere in the middle. So it checks out commit E, and then Git will ask you a yes or no question. Basically, after checking out commit E, you run your project, and then you verify whether the bug actually is there. Let's say, okay, E still contains the bug. So then you tell Git bisect that, yes, it still contains the bug. Then bisect will tell you, okay, now we've narrowed down to commit A to commit E. And then again, all right, commit C, is that a good or bad commit? You tell Git bisect that, oh, commit C is actually green, it's actually good. All right, so it further narrows it down to just 3 commits. And then it asks you again, commit D, is that good or bad? All right, it's bad. Now Git bisect keeps track of, which commits are good, which commits are bad. In those, commit C is good, commit D is bad. Therefore, it tells you exactly which commit actually introduced the bug. It's the commit D. That's what Git bisect does. And occasionally it's very helpful. I've used it maybe a few times in the past couple of years. Nonetheless, I think you should know that, hey, this is a tool there to help you narrow down your bugs in your commits. So that's Git bisect. Something that's really, really interesting that I'm sure most of you know, that there's a thing called Git reflog, right? If you haven't, you should definitely look it up. Git reflog it's almost like the Bible of Git. So you do a Git, you do Git log, you'll see the commits on your current branch. You do a Git log, whatever option might be, it gives you all the commits in all the branches, right? There are hidden things like stashes and hidden actions like rebasing, like fast forwarding, rebasing, merging, and things like that. These are things that are hidden from your Git log. So you can't actually get them out of Git log. This is where reflog comes in. It basically contains every single action ever performed on your repository until they get sort of recycled, which I'll touch on in a sec. So this is what a reflog looks like. So I'm currently on master, which also contains origin master, which is the head of the repository. And I've done a reset at some point. I've committed at some point. I've done a git pull, which typically it's a fast forward. Therefore, a git pull would suffice. Otherwise, you need to do a rebase. I've done a checkout. I've committed a temporary commit. Every little detail is contained within the reflog. So when in doubt, look into the reflog. If you, let's say, accidentally remove something by using git reset --hard, this is where you get the commits back, right? So you don't need time machine, unless you've forgotten to commit and then you hard reset, then, well, Git can't help you because it hasn't actually staged anything or committed anything yet. But as long as things are committed or even just stashed, you can always get them back. Always get them back. Yeah, that's why, which I'll get to in the demo. That's why I wasn't afraid when we were doing that, because you can always get things back. There are small, I guess, exception being, let me see whether, yeah, this is a small exception. There's garbage collection in Git. We probably don't think about this at all on a daily basis when you use Git, right? But there is actually garbage collection because let's say even the pro-admin repo, it's pretty big, right? There's like a lot of commits happen on a daily basis, a lot of feature branches and things like that. The repository will get big, right? So by default, if you haven't tweaked any settings, the ref log is valid for at least 90 days, right? After 90 days, the GC will kick in and then it'll start removing things or it'll start expiring things. So there is a GC. It doesn't really apply to us because our repository is not large enough, but let's say if you've got a repository that's like gigabytes in size, you probably want to tweak your GC settings so that it expires things a bit faster or what have you, so that it doesn't have to deal with millions of commits every single time. So that's, get GC, it'll sort of try to get the delta and try to, what it does is it tries to find all the straining shards or like the shards that are no longer valid. So if you've deleted something and it's no longer in your ref log, then GC will pick it up and essentially throw them away. I'll demo that in a sec. Now, finally, this is not a Git thing. This is more of the command line thing. So because I use mostly command line Git, typing in git blah, blah, blah every single time is very annoying, especially when I'm trying to optimize for speed. Personally, I've got a bunch of Git aliases set up. So, some of the most commonly used GSTs for Git status, Git add, GC commit, GCO checkout, diff, git pull, git push, git log. There's a bunch of aliases that I personally use, which will save you a huge amount of time. And it's probably less error prone as well. So I highly recommend you setting up some of the aliases if you spend a lot of time in your command line. So a typical workflow that I use for rebasing, for instance, I'll check out master, right? Let's say I was on a feature branch. So I'll check out master, do a git pull, and then check out the feature branch that I was on by simply using a dash. You don't need your full branch name, GCO dash. And then I've got a rebase master alias as well. That's a very typical workflow that I personally do all the time. Shell prompt. That's very important because information is everything. So which branch you're currently on, whether there are stashes and things like that. You can find out all information by git status or git branch or what have you, right? But they're annoying. You want them to be visible or more visible to you. So I've got my own, you can find out how my setup is from my .dot files, but this is what my command line looks like, right? I've got my username, I've got my host name, I've got where I am. This is the, most of you probably do as well, the current path. Then I also have the branch names, whether I'm on master, whether I'm on a feature branch. And then also the green tick and the red cross, like whether I've got unstaged or uncommitted code. So if it's a cross, it means that my commit, my Git working directory is not clean. So I have things that haven't been committed. That's what this means. There's also a sign dot. That means I have stashes. Stashes, sometimes you forget about them, right? You do a git stash and then you got distracted and you come back and the stash will still be there until you do something about it. But if you've forgotten about them, then they'll always be there. So that's like a reminder for me that, hey, there are stashes. So try to tweak your command line to help surface those kind of information. I think they're important. And they're a time saver as well. So no longer do I have to do a git status before knowing about anything about whether there are uncommitted code. I don't have to know like which branch I'm on by querying git branch or git status, right? So I highly recommend you tweak your command shell prompt. All right. Now the exciting part is the demo. So I'll give you a very, and this wasn't part of the plan. It just so happened that this morning, Steve and I were working on something, right? And then we actually had to do something with Git. All right, I'll explain what the problem was and then sort of run through it. So we have Panipuri. So this is our Laravel stack. Steve's been working on a feature branch for the past week or two, a week or so maybe. And the feature branch was merged onto master. Now, typically that's fine. One of the only exceptions when that's not ideal is the feature branch actually contains something that we don't actually want to be in the repository. So in this case, it's a staging PEM key, right? We want to get rid of that. Now, if you just revert that commit, the content will still be in the repository, right? So because it's all in the commit history. So what we needed to do, and at that point, the branch was already merged on master. So there are several things that we needed to do. One is to revert the master back into where it was before. Now, one thing I didn't get into was that there is a get revert command. What it does is basically it inverts what you applied in the commit, reverts it, and apply that as a new commit. This is not what we want, because if we did a git revert, the content will still be in there, right? So we want to remove the merged commits from master. And then we need to fix the feature branch itself, because the feature branch is the branch that contains the offending commit. So we want to get rid of the commit. So what we needed to do was to, first of all, use git reset to reset the master branch and force push it so that the commit would no longer be on master. However, if we only did that, the commit will still be in your repository. So we needed to essentially reset master back to where we just before we merged the feature branch into master. And then for the feature branch itself, we need to remove the commit and force push the branch if we have to, and then merge the branch into the master. Now, I'll show you what it looks like. If you've done something like this before, it should be relatively straightforward. If you haven't, it might be somewhat confusing, but just stay with me. Now, I've made a Panipuri demo repository. Can everyone see the text? Cool. I've made this repo. I've already sort of reverted it back into the where it was before. Basically, the feature branch got accidentally merged into master with the offending commit. So this is where it is now, right? So if we do a git log, again, this is the aliases that I used. This is a git log alias. So there's like this merge was caused by git pull without using rebase. So that's an example. So that's a proper merge pull request action by GitHub. These were the commits on the master that got merged into the feature branch before it got merged into the master. You can see why it's confusing, having merges go both directions. So when I was talking about use a rebase before you merge, was to avoid situations like this. Avoid situations like having something merge into a feature branch and then merge back into master. It's very confusing when you look at the timeline. So you want to avoid doing that. So these commits are from the feature branch. And if we scroll down a little bit, one of the commits was the offending commits, I think was the added PEM key somewhere. So we want to get rid of that commit, that PEM key commit. So this is what we have to deal with, right? So the ultimate goal is to fix this locally, force push it onto GitHub, so everything will be fixed. Now, before you do that, force pushing is very, very dangerous. So use it, only use it when you know exactly what you're doing, right? Now, just to be safe, what I would recommend you to do is that you look at the head, and you copy paste the SHA to know that this is what you're replacing your work with, right? This is what you currently have on GitHub. So paste that somewhere so that later on, when you supposedly fixed your repo, you can compare whether you've actually fixed your repo, whether you've forgotten anything, right? So let's say, you paste it somewhere here, right? I've got it here. This is the original master, right? So that's the SHA. All right. So now that we've backed up the SHA, we can start performing surgery on the repository locally, right? So if you remember the steps that we needed to take, first of all, git reset your master, right, back into a healthy condition, a healthy state, and then do work on your feature branch. Git reset master is relatively simple as long as you know where to reset it to, right? So at that point, you need to look at, all right, let's keep scrolling down. There are quite a few commits on the feature branch, but this is the last commit before we kind of forked into different branches, right? So this was most likely the last healthy commit on master. So you note this down. Now, one thing that we discovered as we were performing work was that if you look at this tree here, right, we have those stars indicating these are the commits on a feature branch, but there's also a blue line here. It means that there's another branch somewhere else. It turns out these 4 commits happened after Steve's feature branch, which caused that merge commit master into the feature branch. So in order for us to restore the previous master, what we need are these 4 commits, because these 4 commits are not on the feature branch itself. It got merged into them, right? Part of the fix, we also want to get rid of the reverse merge. So note down those 4 commits, which we need on the new master, as well as the last working commit on master itself. So these are the important ones. Now, what we can do, we copy paste this last working SHA, and I've already sort of backed up the 4 commits that we also need, right? So I'm currently on master, right? All we need to do, git reset, --hard, and paste in the last working commit on the master branch to reset master back into that commit. Let's do that. All right, we're still on master. If we do a git log, you can see now this is the latest master, which is indicated by head. Head is always the latest on your repo. So we've got that, right? Now, what we need, we can't forget about these 4 commits. We also need them in master. Now, instead of copy pasting a bunch of things, there is another Git concept called cherry picking. What cherry picking does is you copy paste, and you have to do it in order. So from oldest to newest. So you copy paste the first one. It's called git cherry-pick, right? And because I do it often enough, I've also got a shortcut GCP for cherry picking. So you want to paste that what this does is it cherry picks a commit onto the current branch. However, the difference is very similar to when you're doing your rebasing. So it tries to apply the same content onto your current branch, but it'll make a new commit. So if we do this now, it'll go through. It's a fairly large commit. If we do the git log again, it's the exact same commit with entirely different shards. So these are different shards, right? So that's the important bit. So if there are, let's say, conflicts, then it'll kick you into git rebase interactive, and then you have to fix your conflict before you can actually cherry pick it onto your current branch. So there's actually a shortcut to cherry picking a bunch of them together, but let's just, cherry picking them one by one, right? So let's cherry picking the second one. Let's do it for the third one. And the last one. Now, if we do git log again, that's where we were before, the last working commit on local master. These are the 4 new commits that we applied on master. So at that point, I'm happy with master because master is now sorted. Everything else is contained within the feature branch, right? All right, now let's look at the feature branch. So I've also got another alias for everything. So this was the, I guess, the feature branch was, anyway, it doesn't matter. So one other thing that you probably would have done before was to also look at your feature branch and identifying the oldest and the newest, probably not as important, the oldest commit, just to identify which commits were in your feature branch so you can actually fix them. So at this point, master is fixed, right? So we want to fix the feature branch, remove the commit, and then at some point, once we're happy with the feature branch again, we'll merge it back in. Let's see, what do we need to do? Now this repo is slightly different because it was a snapshot of the fixed version. So what you see here is actually the current feature branch that was already cleaned up. So we need to go back a little bit, I believe. Or let's see, have I? So I believe that was the unfixed auth. Let's have a look. Do we see the added PEM key file somewhere? Anyway, I've got another one here. Hang on. So something to remember next time is to also back up the SHA of your unfixed feature branch so that it's easier to get to. You can always get to them via reflog, but a lot of times it's a bit hard to see what actually went on there. A bunch of rebasing, origin, the auth. So all the rebasing commits you're seeing now are the rebasing that we did to actually fix the branch itself. This is the original pool. Alrighty, here we go. All right, so at this point, that was the head at the time, which contained that was the broken feature branch that was merged into master at the time. So if we keep scrolling, these commits were all on that feature branch. So we go back. So updated git ignore was the first commit, and then that was the last commit. Now what we need to do is we've already fixed master. So this feature branch is what we needed to fix. So get the latest SHA from that feature branch, because once you check out that, you check out the feature branch at that time, right? So you check it out. Now we're actually on the broken feature branch. If we see here, this is the offending commit, adding the PEM key file. So what we need to do to remove this is to actually do a git rebase and remove that commit. How you do that is we want to rebase. You need a starting point. The starting point is one commit below your offending commit, right? So you copy that. Again, I've got a bunch of aliases. What you do is essentially git rebase -- interactive. This is how you normally do a git rebase. And that's why I use a shortcut, GRI, and paste in that commit. That was the commit just before the offending commit. You do that, Git will try to do a bunch of things, and then it presents you in your editor of choice, in this case in Vim. I don't actually use Vim, but you'll see that add a PEM key is right there. All right, now if I scroll way down to the bottom, Git actually explains a bunch of things to you. It tells you what you actually need to do. There's a bunch of commands. By default, it's picking every single commit. So if you just save this file and quit it, Git actually does nothing because there's nothing to do. It's picking every single commit. We want to drop a commit, so removing a commit. So it's drop or D as a shortcut. So what we do is we go back up the top, we delete pick and replace it with D. That means we're removing this commit and keeping all the other commits. At that point, you can save, and it does the rebasing. Now, if we look at the history again, all the commits are there except for the add PEM key. So add PEM key is vanished. So this is what we want. Now, at this point, luckily I've got this here. At this point, even though it's not on master anymore, it's not on your feature branch anymore. However, git reflog, if you remember that, if you do a git show, that was the offending commit, it's still there, right? Even though you've already removed this, it's still in there, right? And that's because git reflog, and that's where reflog and GC come in handy. So let's not worry about that for a second. Let's just say, okay, now we've fixed this feature branch. Now what we need to do is essentially to merge it onto master. But before we do that, let's do a rebase, right? So git rebase master. Now I'm not gonna actually go through the rebasing because we did it this morning. We had to rebase about 6 or 7 times, right? So it'll say, hey, you know, there's conflicts, you have to fix it manually. If you do a git status, it shows you that these links are modified by both incoming and your local copy. So we're not going to go through that. What I can show you, so let me just get rebase abort to abort out of it. So I'll switch back to master and I'll show you what we ended up with. Let me try to fetch again just in case. All right. I have to show you the origin master in this case. All right. So what we, oh, I haven't actually merged in that. We tried to rebase and I think we did a good job, but we actually forgotten something. So that's why we had like a fixed rebase commit. If you did everything perfectly, you actually shouldn't actually even need to fix your rebase. Now, I'll show you what it means. So after we've done all the rebasing, the second commit was the commit that we ended up with, right? So I'll show you that. So let's check out that. Now, let's pretend that what we've done was to actually rebase and we're now on the feature branch that's rebased off the master, right? So all the commits are grouped together now. Now, this is when backing up your initial commit on the origin comes in handy because we've done a bunch of things, right? We've done, you know, rebasing and resetting and everything. How do you actually know your fix worked? There's no way to know that, right? Well, we've backed up that initial master. That was the broken version that contained the PEM keys and everything. So what we can do is we can do a git diff. So git diff, compare it to that SHA. What that would do, that will tell you exactly the differences between your fixed version and your origin version. So in this case, in our fixed version, the key is removed, right? And then it just so happens that we missed some other small changes. I think we've done well because that was kind of the extent of it with some white spacing stuff. This is how you verify whether your fix actually worked or whether you've missed anything. So this is how we know that, hey, wait a minute, we actually missed that small part during the rebasing. So during the rebasing, we forgot to look at that file and it ended up being different. So then we essentially applied that specific commit to essentially fix the rebase, right? And then what we ended up is essentially a fixed version. So at the moment, if we look at the Panipuri repository, the master is already fixed. So we force pushed master, right? You can see that my name wasn't there, but because I was the one doing the force pushing. So master is fixed. The feature branch is fixed as well. Now, if we switch back to the actual Panipuri repository, if we do a log, it's very clean. Like this is the master branch, and this is the auth branch, which has already been rebased. It's on a linear path, as you can see. So right now, if I do a git merge master, it wouldn't actually create a merge commit. It'll just be like, hey, you've merged. So it'll move the head in the master here. That's what fast forward means. And then if you, normally we do it on GitHub, so it doesn't really matter. GitHub actually forces a merge commit. But if we were to do it locally, then in this case, personally, I would do a rebase as we've already done. and the merge dash dash no FF, no fast forward. Yes, that's it. Any questions? Is it confusing somewhat? Like when you know I guess how Git works, and then knowing that ref log is always there until you, actually 2 more commands I'm going to show you, because I mentioned Git GC before, right? So let's see the offending commit, which was it? Is it that one? No. Yeah. So if we do a git show now, it's still there. So it defeats the purpose of doing this whole exercise, right? You know, if some like a hacker got a hold of our repository, technically they can still see the file. Now that's when reflog and GC comes in handy again. So what we can do, just in case I forgot about the commands, what you do is you run the reflog, you try to expire the objects, because the objects are no longer attached to any real branches or whatnot, so they like invalid. They will eventually get removed, but we want to speed up the process. We want to expire all objects and essentially, yeah. Anyway, so this command will expire all objects. Before I run it, let me just show you git reflog again, right? It contains a bunch of junk in it. We run this command, right? And then we see git reflog. It's empty. So everything in reflog is now emptied out. So they're no longer there. Because they're no longer there, the commits at this point are still there. It's still there, right? Why is that? Well, because it's still contained within your repository, even though reflog no longer references it, right? Then this is where GC comes in. GC by default, if you don't specify any options, I believe it cleans up everything older than 2 weeks. So I believe if we do a git GC on its own, let me just test it out. I haven't actually tried this, and then do the git show. It's still there. So what we need to do is we need to do GC and prune everything right now, or basically prune everything. So we run this, that will further sort of remove junk out of your repo. And now, if you do that show, it's no longer there. This is what we want. Physically deleting the commit out of the repository. Now we've achieved what we set out to achieve. And then once we force push in everything, it'll override the origin as well. So that's it. I guess my final point would be like, you know, depending on how you are familiar with Git, you might or might know all the things that I've touched on. Look into them. I think they're very useful, especially when you like accidentally did something, or you accidentally merged something that you shouldn't have, or you just want to revert something. Like look into some of the key concepts. They will save you, and they will sort of help you have a cleaner Git repository. Like if you do a Git log, this is linear. Linear is good. It's very easy to follow. You know exactly where things stand. If you keep scrolling, there's like a few merges. They're very easy to see. But if we were to do like merging like back and forth and all over the place, let's see what pro-admin looks like. Yeah, so when you do like git merge, like back and forth, like the lines will get wider, and that's less desirable, because then it's harder for you to keep track of which commits belong to which branch, right? And I've seen like code bases, and this is actually not that bad, but I've seen code bases where there's like dozens of branches running concurrently, and all because of like merging hell happening in the repo. So I would say keep rebasing. Like if you are working on your feature branch for a while, like personally, if I were to work on a long running feature branch, I'll rebase at least once a day. The longer that you leave it, the harder it is for you to rebase, because the way rebase works is that it rebase one commit at a time. So if there are some conflicts that Git cannot resolve on its own, it's not intelligent enough, you end up changing or resolving the same conflicts over and over and over again. If you do run into that situation, normally what I'll do is I'll try to squash the commit. So Git squash is another concept. Please look it up. Essentially, it squashes a bunch of commits into one or like into a few commits, so that you only have to do rebase once or a few times instead of like 200 times if you've got like 200 conflicting commits. So things like that. Just look into how to use Git more effectively. I think it'll save you time. It'll keep the repository itself clean, and that's good for everyone. So thanks.